us see the numerical given over here. Example number 6. A bucket shown in figure is made of iron sheet. Find area of iron sheet required to make the bucket. Also find volume of water contained in the bucket. So what we have to calculate? We actually have to calculate the area or metal sheet, iron sheet required to make the bucket. Now this bucket, concentrate on this bucket itself. This is the upper open portion of this bucket, which is having diameter 300 mm, and the lower diameter of the bucket is 200 mm. This is the handle of the bucket, which will for the decorative purpose only. Height of the bucket is 500 mm given to you. So first of all, we have to calculate area of iron sheet required to make the bucket. Now, according to theorem number 1, for finding the area, we have to take length as a revolving figure. So you can see in this figure, this is the axis of revolution, about which the lines are to be rotated. Why lines? Because we have to find area, so we have to rotate lengths. Here it is, two lengths are to be rotated. Two lengths. First length is this inclined line, and second length is this horizontal line. Upper portion will be kept open to fill up the water. Okay, so there are two parts only. First one is inclined line and second one is horizontal line. This inclined line length is not given. For that, you can see this upper length is 150 mm from the rotational axis, which is equal to half of this 300. Okay, semi-vertical figure, only one side. Half of this lower diameter 200 is this 100 mm. So the remaining gap, you can see this vertical height will be 500 mm, and this base of the smaller triangle will become 50. How it is 50? 150 minus 100. So by applying Pythagoras theorem, we can find this integration, which is equal to under root of 500 square plus 50 square as in the table. You will find this answer in your calculators. For length AB, the horizontal length is already given to you 100 mm. By adding these two lengths, we will get sigma L, in summation of both the lengths. Now, where is the CG? Where is the CG of this particular part? For the horizontal line, CG will be at this midpoint. From the rotational axis, it is measured as half of 100, which is equal to 50. Now, for BC, means this inclined line, CG will be at the midpoint. From the rotational axis, point C is at 150 mm. And from the rotational axis, point B is at 100 mm. So by doing average, 150 plus 100 by 2, you will get the answer 100 plus 25, like something that. Now, you will have to multiply length into x. So here it is L1x1, here it is L2x2. Or there is some mistake in this table, then you can calculate at yourself according to the method. Now we have to find area, which is equal to L into theta into x bar. X bar will be calculated like this: sigma s upon sigma L. Means L1x1 upon L1 plus L2. L1x1 plus L2x2 upon L1 plus L2. By replacing the values, you will get x bar equal to 112.55. So area will be is equal to L into theta into x bar. So final answer, area is given to 42664.36 mm square. So here is the example number 6, in which we have calculated area of iron sheet required to make the bucket. Now what we are requiring now is to find the volume of water contained in the bucket. So for that, area must be revolved about the rotational axis. Let's see, this is the area which should be revolved. First one is triangle, and second one is this part rectangle, and second one is this part triangle. So dimension of the rectangle is horizontally 100 and vertically 500 given over here. Base of the triangle is 50, height of the triangle is 500. Let us calculate the areas first. For the rectangle, area will be 100 into 500, which is equal to 50,000 mm square. What is the area of the triangle? It will be 1/2 base into height. So base is 50, height is 500. So 1/2 500 into 50 is equal to 12,500. What is x coordinate of the CG? For the x coordinate of the CG, concentrate over here. In this rectangle, CG will be at the center. So x coordinate, which is equal to 100 by 2. So 100 by 2 is equal to 50 mm. Now for triangle, CG is somewhere over here. Means the distance is base by 3 plus adding this distance to reach the revolving axis. It is 100 plus 50 by 80. Answer will be available in your calci. Find A1 x1 and A2 x2 for part 1 and part 2. So this is sigma A and this is sigma AX. Sigma A means addition of these two values and sigma AX means addition of these two values. Now find x bar, sigma AX upon sigma A. You will get this answer. Volume of surface of revolution is equal to A theta x bar according to formula. But if all the values, we will get volume is equal to 24.86 liters. To make it in liters, we have to convert first mm cube into meter cube and meter cube into liters. You have to calculate mm cube into meter cube at your own. But I am giving a hint to you, 1 meter cube equal to 1000 liters. So this is 1 meter cube equal to 1000 liter, 24.86 liters. So here is the sum number 1 in which we have calculated the volume of water contained in the bucket. Now see the example number 2 in which we have to calculate volume of this portion about y axis, means about AB axis. Okay, in this part 1 is semicircle, part 2 is small triangle and part 2 is bigger triangle. From part 1, part 2 and part 3 are to be subtracted. Let us see the calculation. First, in the part 1, semicircle area will be equal to pi r square by 2 according to formula. As you can see, the radius of the semicircle is 2 meter. So pi r square by 2 will be pi into 2 square by 2, 6.283 meter square. Now x1 means x coordinate of the CG. X coordinate will be this, means according to formula 4r by 3 pi. So by replacing the values, you will get the answer. What is y1? So looking from the bottom x-axis up to this CG, y1 will be 2 meter, means radius itself. Now what is part 2? It is triangle, upper triangle. CG of the triangle is somewhere over here. From the vertical height, it is base by 3, means 1 by 3. It is 0.333 meter. From the bottom, it is height by 3, means this 1 by 3. And to the x-axis, it will be 3 meter. So 3 plus 1/3 of 1 is equal to 3.333 meters. Now part triangle, lower triangle. Here it is the lower triangle. CG will be somewhere over here. It is base by 3, means 1 by 3 of 1.333 meter. And here it is 3 by 3, which is equal to 2/3 of 3, 2 meter. And area of the triangle is equal to 1/2 base into height, 1/2 3 into 1, which will give you 1.5 meter square. Now let us see the calculations ahead. X bar and y bar. What is x bar and y bar? Actually, here is x bar and y bar given to you. From part 1, part 2 and 3 will be subtracted. So by replacing the values, you will get x bar equal to 1.088 meter and y bar equal to 1.844 meter. Now main important thing is to calculate the volume of revolution, which will be equal to theta x bar. So by replacing the area, what is area? So area is given here, A1 minus A2 minus A3. Theta is always 2 pi radian. Up to 360 degree we have to revolve the object, and x bar equal to this. So by replacing the values and doing calculations, we will get the volume of this particular portion, 29.279 meter cube. So students, these are the two numericals of Pappu's guldinus theorem. Now you have practiced these sums, so you have to speed up yourself and do the practice of some more examples at your own. These two examples are again and again repeated in your notebook. Okay, then and then you will masterize this method. From today onwards, this chapter will close, and from Monday onwards, we will start another chapter to complete our remaining syllabus. Till then, thank you students, thank you very much, and